In this problem, we're going to look at polar area. So we want to find the area of the region enclosed by one loop of the polar curve r equals 2 sine of 5 theta. So first, let's take a look at the graph of that curve. So it's got 5 loops, and we want to find the area enclosed by one of the loops. And remember that the formula for area is the integral from a to b of 1/2 r squared d theta. So first we need to figure out what our a and b are. So let's just look at this first loop here. We want to find what r is when we start out here and when we come back here. So that's going to be when 2 sine of 5 theta is equal to 0, and that's the same as having sine of 5 theta equal to 0. So when is sine equal to 0? Well, that happens when the angle is a multiple of pi. So in this case, that's when 5 theta is equal to some multiple of pi, where k is any integer 0, 1, 2, 3, and so on. So we'll just look at, here we want to look at the first loop, so we'll look at the first 2k, 0, and 1. So when k is 0, 5 theta is equal to 0, and that means that theta is equal to 0. Alright, and then what about when k equals 1? Then we've got 5 theta is equal to pi, so theta is equal to pi over 5. So those are our bounds. Our a is going to be 0 and our b is going to be pi over 5. And then for the inside, all we need to do is figure out what r squared is, and that's easy. So r is 2 sine 5 theta. That means r squared is going to be 2 squared is 4 times sine squared of 5 theta. So now we have everything we need to set up our integral, and we'll go ahead and do that. So our integral, the area is going to be the integral from 0 to pi over 5, 1/2 times r squared, which we said was 4 times sine squared 5 theta d theta. So now we can go ahead and work on this integral. So first, let's do a little bit of simplification, and the first thing I'm going to do is multiply out this 1/2 times 4, which is 2. Now I've got a sine squared here, so I'm going to use my half angle formula, and that sine squared is going to become 1/2 times 1 minus cosine of 2 times whatever I have inside here. So 2 times of 5 theta is going to be 10 theta d theta. Alright, and then this 2 and this 1/2 cancel, so that's just 1. And now we can integrate. So if I integrate 1, that's going to be theta, and then the integral of cosine is sine of 10 theta, and since I've got this 10 in here, I have to multiply by 1 over 10 out front, and then I'm evaluating from 0 to pi over 5. And now we can just plug in our bounds here, so let's do that. So first, if I plug in pi over 5, theta is pi over 5 minus 1/10 times the sine of 10 times pi over 5 is 2 pi for my first term, and then my second term is 0, so if I plug that in, I get 0 minus 1/10. The sine of 10 times 0 is 0. Now, Sine of 2 pi is 0, so this whole term just goes to 0. And then sine of 0 is also 0, so this term goes to 0. And I've got a 0 here, so all I'm left with is this pi over 5. And that's my answer. So my area of one loop of the curve is pi over 5.